Hello friends, welcome to our channel. In this video we will discuss time division multiplexing that we called as TDM. So let's get going. Before going in the detailed discussion of the time division multiplexing, first we discuss what is multiplexing and why we are using this multiplexing. Multiplexing is the process in which we transmit the multiple signal over the common channel. So let's suppose we have a two signal X1 and S2 which occupied the range of frequency from 0 to 20 kHz, and let's suppose second which occupied the range of frequency from 5 to 10 kHz. When we transmit these two signals over the same channel, then there are chances of the interference. So in this way we can't recognize which signal is which one and we lost our signal information. To overcome this problem, we use the process modulation, in which we transmit our first signal with the carrier frequency Fc1 and transmit second signal with the carrier frequency Fc2. So these two signals occupied the different range of frequency. When we transmit this signal, then also they occupied the different range of frequency. So there is no interference in the two signal and we save our information. So this is the way in which multiplexing works, because we transmit the two signal over the same channel. In this way we save our channel bandwidth, because in the communication field transmission cost and the bandwidth used are the two important parameter, and we always try to save them. The TDM. The basic principle behind the TDM is that complete channel bandwidth is allocated to one user for a fixed time slot. It means each user can use the full bandwidth available but for a fixed interval of time. In this way, we save our bandwidth and the transmission cost. Let's suppose we have a three user M1, M2 and M3. They want to transmit their signal. So what commutator done? Commutator is a device which connect one by one for each user for a fixed interval of time. First it connect to the M1, in which M1 transmit their signal, and then after a fixed interval it connect to M2, then M3. In this way this commutator helps to transmit the signal over the same channel, and we save our time and the transmission cost. When each user pass their signal, first the signal passed through the LPF. LPF is the low pass filter which works as the anti-aliasing filter which avoid the signal losing at the receiver side. Then signal passes through the commutator. Commutator is a rotating switch which rotates in the anti-clockwise direction with the uniform speed. Time taken by the commutator to make one complete rotation is called as the time frame, and it is denoted as the TS. Commutator is used to sample multiple message signal simultaneously. Then the signal is passes through the quantizer and then encoder. Then in the path we have a regenerative repeater, and at the receiver side we have a decoder. This process is same as we discuss in the PCM, that is pulse code modulation. If you are directly watching my this video, so please watch the PCM video. Then signal passes through the decommutator. Decommutator is just opposite of the commutator. It rotates in the clockwise direction with the uniform speed as the commutator. In the reconstruction of message signal, finite amount of quantization error will present, and then signal passes through the low pass filter and we recover back our original message signal as it is. When the message signal is passes through the low pass filter to commutator, let's suppose at T1 it takes the sample of M1 as A. Then after it connect to the M2, and let's suppose at T2 interval it takes the sample of M2 as B. Then it connect to the M3, and at T3 it takes the sample of the message signal 3 as C. In this way, taking the sample of each message signal, then commutator after the TS interval, that is the time interval in which rotation of one complete commutator is complete, it connect again to the M1 message signal and at T1 plus Ts it takes the sample of the message signal 1 as D. Then at T2 plus Ts it takes the message signal M2 sample as E. Then at T3 plus Ts it takes the message signal sample 3 as E. So in this way the commutator takes the output, and this sample output is the commutator output which is goes to the quantizer. In the one time frame, that is Ts, the number of user we are multiplexing or number of signal that we are multiplexing is denoted as the capital N. In our discussion, as we are using the 3 signal to transmit, so the capital N value in our discussion is 3, and each sample or each user is represented, let's suppose, as the 2 bit 0 and 1. So the small n value is 2, and that is called as the number of bit per sample. Bitrate of the TDM, that is RB, is NNFS bit per second. If we allow the one user to transmit the signal over the channel, then capital N value is 1. So RB is NFS, that is the same that is in the PCM. So TDM is nothing but the extended version of the PCM, in which we allow the multiple user to transmit their signal over the same channel. Let's suppose that the commutator take 1 millisecond of time interval to make a one complete rotation. So to find the speed of commutator, we perform as 1 by Ts, that is 1000. That means in a 1 second commutator is rotating 1000 rotation.